So this is the graph that I'm giving you to discuss limits, and we are going to look at this graph. I actually have a copy of the graph for anyone who missed class today with all of the questions. So you would want to have that copy of the graph of this paper in front of you while you are going over the answers, so you can look at the graph and be able to see the questions at the same time. I really don't have a way to write all of the questions and show you the graph at the same time so we can talk about it. So we're just going to go with this plan. You need to come get the questions from me, and then you need to watch the video. Question number 1. All in red, all of this in red. This is all g of x. It is a non-continuous function. It is doing several different things, and there are breaks in the function. However, that is all g of x. So anytime we're talking about the function, we are talking about what is in red. The first question that you all have in front of you is, what is the limit of g of x, or what is the limit of my function as x approaches infinity? What that means is, as we are going towards positive infinity, we're moving along towards positive infinity, where does my function end up? Where does my function end up? Is it going up to positive infinity? It's going down to negative infinity? Guys, what is it getting close to? That line. And what is this line called? An asymptote. And where is that asymptote at? H. So the answer for number 1, as our function g of x moves towards positive infinity, we are actually getting close to h. Our limit as we approach positive infinity is h. Number 2, and let's try not to scream everything out. I know it's hard because you're so excited. But if you look at our function, it says, what is the limit of g of x as x approaches negative infinity? What's going on down here as we go towards negative infinity? It is I. It is I. So the correct answer for number 2 is I, because that function is going to get closer and closer and closer to the asymptote at I, but it will never cross it. That's the whole point of a limit, ladies and gentlemen, is that we can get close and close and close and close, but we don't actually have to go to that particular point. Anybody have a question about number 1 or number 2? Question number 3. It asks us the limit of g of x as x approaches a, and then there's a little plus after the a. What does that mean? We're approaching from the positive side. As x approaches from the positive side, we're moving from the right. What is happening to my function? What does it do when it gets to a? It goes to positive infinity. Good, Allie. So the correct answer for number 3, as x approaches a from the positive side, it does go to positive infinity. Now we want to talk about the limit. And Dalton's already talking. He's so excited. Now we're going to talk about the limit as our function approaches a from the left-hand side. That's what a and then a negative afterwards. That means we want to approach a from the left-hand side. If we're following our function and we talked about the limit getting closer and closer and closer and closer to a, where is it going? To positive infinity. Good, good. So our answer for number 4 is positive infinity. Now, 7:45, 7:50 is awful early in the morning. I am not a morning person. In fact, in the summertime, I like to sleep till about 10. So this morning, when my students were struggling with number 5, this was the best I could do. You're going to have to forgive me, but this was my explanation. Number 5 asked me what the limit of the function is as x approaches a. It's not a from the positive side, and it's not a from the negative side. It's just a. Well, in this particular case, we come towards a going to positive infinity, and on the left-hand side, we're going to positive infinity. So since they match, and they're both going to positive infinity, do I have a limit for a? Yes, and what is it? Positive infinity. This morning, I told my students, if you have a shoe on your right foot, and it's the same shoe that you have on your left foot, they match, and you can leave the house. That means it does work. You have to have 2 matching shoes. Sorry, I told you it was bad. I knew it was bad. But if your right-hand side and your left-hand side match, then you do have a limit at A. You can always have a limit of A as it approaches the positive, and you can always have a limit of A as it approaches the negative, but there is a possibility, Carly, that if they don't match, then we'll talk about that. We've talked about that, what to write if they don't match, but that's coming up in just a second. So our answer for number 3 is positive infinity. Our answer to number 4 is positive infinity. And our answer to number 5 is positive infinity. So if we look at number 6, number 6 asks us to find the limit of our function as we approach b from the positive side. Well, as we're coming down this red towards b, what can you say about my limit? Where is it going? To negative infinity. Very good. So the answer to number 6 is negative infinity. Number 7 asks me to find the limit as x approaches b from the negative side. Well, it's not b. B is our x-intercept. I want to know my y-coordinate. Or b is my x-coordinate. What is my y-coordinate? What are we getting close to? To 0. To 0. We're coming down to 0. So our correct answer for the limit of g of x as x approaches b from the negative side, thank you, Josh, is 0. The correct answer for number 7 is 0. Now this is where my conversation of the shoes gets important. Question number 8 says, what is the limit of g of x as x approaches b? Not b from the positive and not b from the negative. B from both sides. Do my shoes match? No. So mean girls say, thank you, Allie. The limit does not exist. For number 8, you are not going to put undefined. You are not going to put no solution. You are going to write does not exist. There is no limit for g of x as it approaches b. You can do b from the positive and you can do b from the negative, but because my shoes don't match, does not exist. Question number 9 asks me to find the limit of g of x as x approaches c. Don't scream anything out. As x approaches just c, not c from the positive and not c from the negative. C. Why does the limit not exist? Are they going in they're going in two different directions, right? We're not going to the same place at all. If you're approaching from the negative side, where am I going? To negative infinity. Be careful if you're approaching from the positive side, where am I going? F. Thank you, Brody. Thank you. If you're approaching from the positive side, it's F. So because they don't match, my answer for number 9 is does not exist. Number 10. What is the limit of g of x as x approaches d? D as in dog. What is the limit of g of x as x approaches d? Are we converging on one point? Everything coming in and we are matching at, not D, what is my y coordinate? 0. The correct answer for number 10 is 0. We are coming in from the left and the right and we are meeting at D, 0. My x is given at the bottom of the limit. It says x is approaching D. That's where we use the D. And it's the y coordinate of 0. That is where we are left. Number 11, 12, and 13 are completely different. Are they limits at all? They are not limits at all. Number 11 tells me to just evaluate the function at A. What is my value of the function at A? It's what? Well, it's not that the limit is positive infinity. We have an asymptote there. So it is undefined. Don't we normally write undefined for an asymptote? That's what you said. Good. Number 11 is undefined. If you wrote no solution, I probably wouldn't mark it wrong, but a calculus teacher probably would. Just FYI. What is my value of the function? What is the value of the function at B? Be careful. What did you say, Ryan? M. Ryan's right. For number 12, the value of the function at B is M. Even though the limit from the left is coming to 0 and the limit from the right is negative infinity, that open circle does not have a value. The value comes from this red dot up here. And that red dot is at M. Uh-oh, I'm running out of time. What is g of 0? At 0, what is my value of the function? K. At 0, the value of the function is k. If you go to 0 and go up, our function is at k. Why would 14 be k also? When our function is approaching 0, it is going towards k from the left and from the Right. So our shoes match. Everybody say goodbye.